Welcome to PARIPOORNA Academy. I am J. Tabital and today we are going to discuss on the topic of electromagnetic waves. So, these EM waves are created due to the oscillation or due to the vibration of the electric field as well as the magnetic field, and the wavelength and the frequency of this EM waves, that is the electromagnetic waves, will vary for a very long wavelength, likewise for extremely very short wavelength. And here we are going to discuss what is the source of the EM wave and what are the basic properties on this EM wave. Likewise, we are going to see the intensity of the EM waves, and finally we are going to see the electromagnetic spectrum, which was a very interesting topic, and finally we are going to do some problems based on these concepts. So now let us move on to the presentation. So before that we are going to see what is displacement current. So it is that current which comes into existence, which means in addition of the conduction current whenever the electric field, so and the electric flux will change with respect to time. So during the existence of the current in the electric field, the electric flux will change with respect to time. So this is equal to epsilon naught times, that is the rate of change of the electric flux through a given surface. So we can write it in the formula as ID is equal to epsilon naught into d phi E divided by dt, which is nothing but epsilon naught A into dE by dt. So here comes the modified Ampere circuital law. So in lower classes we will study the Ampere circuital law. Here we are going to see the modified Ampere circuital law. So it states that the line integral of the magnetic field B over a closed path, which is equal to mu naught times the sum of the conduction current IC and the displacement current ID threading the closed path. So this is the modified Ampere circuital law. So that can be represented as integral of B vector into dl vector, which is equal to mu naught. So the statement what we have learned here is in the form of a formula there. So integral of the line integral of the magnetic field B over a closed path, that is why we are using that symbol for the closed path integral, and the sum of the conduction current IC and the displacement current ID. So you can see mu naught into IC plus ID. So mu naught into IC plus the value of ID is epsilon naught d phi E by dt. So the sum of the conduction and the displacement currents has an important property of continuity. So these two currents have the property of continuity, that is the sum remains constant along any closed path. So here comes the electromagnetic wave. This is the main topic of today's session. So an electromagnetic wave is a wave which is radiated by an accelerated charge, that is the oscillating charge. So we can say the charge which is moving. So accelerated charge, and which it will propagate through a space as coupled electric and magnetic fields, oscillating perpendicular to each other and to the direction of propagation of the waves. This is nothing but the electromagnetic waves that you can observe it from the image. So where is the wavelength and the propagation of the waves, how it is propagating, so that you can observe it from the image, as well as for the electric field and the magnetic field.